remember students that the social media people are waiting, they've made your pictures with your practicum. Mentor coming up on 9th. So practicum mentors probably defined. Internships with our MSDS, our Masters in Data Science students, that's something that's starting next year. So we're exploring opportunities with practicum partners to get a team of interns to come work on the data science problem at your company. So if that's something that sounds interesting. Back in the room. You can also grab really happy to here today for a regular data science roundup. The data science roundup might have already read Abhay's post, which I thought was especially good. So I'm especially excited for his talk. So he's going to talk to us about item.
Hi everyone, this is clear, right? Yeah. Hi. So this is the first time I'm talking about this outside of Instacart. So feel free to stop me if I'm not being clear, if I'm not explaining anything clearly. Yeah. So a little bit about me. I've been working at Instacart for last a year and a half. I work as a senior machine learning engineer, and so Instacart has this new set of problems which no other company has faced before, and these directly relate with how good the quality of our service is. And the work that I do is, I would say, at the intersection of recommendations, search, and logistics. And especially today, I'm going to talk about something which is, I would say, falls into logistics, maybe recommendations as well, and that's the item availability model. So, I'll give a brief overview about what Instacart is, how the business model works, then what the availability problem is, how do we train the model, and so the most important thing is how did we go ahead and integrate into the product, which is in itself a different challenge. And finally, we'll talk about some of the engineering aspects, like how do we score so many billions of items in such a short time. So, anyone who has ordered from Instacart before? Oh, okay, that's a lot of people. So as you all know, Instacart basically delivers groceries from stores which are near you. These are existing stores like Aldi or Kroger's and many others like that. And we can deliver them in as little as an hour. So in a way, we like calling ourselves as a four-sided marketplace where customers are the most important side. And then we have the shoppers. So shoppers are basically kind of like Uber drivers. These are engaged by Instacart and they accept your order, they go to the store, they pick all the items and then they deliver it to you. And one of the most important interaction that happens is between the customer and the shopper. When the shopper is picking items, they can ask the customer what replacements they want. If this item is not there, what else should they buy, and things like that. The third most important side are the retailers themselves. So retailers share with us data about what items are there in their store, and we just show the same items to the customers when they come onto the website. The other aspect is that customers are also loyal to some grocery chains. Like some people really like Whole Foods Market, some people like Sprouts, and they prefer their groceries coming from those same stores. And that's why we stick to the existing stores rather than just like bringing up our own stores everywhere. And the final one, but something which people don't realize, are the CPG companies themselves. Instacart is also ads platform, and that we want ads to be one of our major revenues. So CPG companies can bid on ad slots on Instacart, and that's their way to increase their sales. So a lot of people ask me, like, how big is Instacart? Like, how many big cities are you there in? And it usually perplexes me because Instacart is today really big. It's there in all the 50 states. It's there in Alaska. It's there in Hawaii. It's there on like far-fetched islands. It's there in rural areas. We can deliver groceries to 80% of Americans today, and that's a really large scale. We are operational in Canada as well. And in terms of partners, we have like 300 plus retailers. These are all very big retailers which are present across the US, as well as a lot of regional retailers which are famous in that specific state or that specific small region. So in terms of order flow, as a customer, you come onto the website, you select a store, you shop for your groceries, and then you place an order. You choose when do you want them to be delivered. And once you do that, it goes to the shoppers. They accept your order, and then they drive to the store, start picking items. And while they are doing this picking, they scan each and every item. And this is one of the most important signals that we get to predict availability of items. So what is the availability problem? So knowing which items are there in the store. So let's say you picked, you went onto the website, you picked Whole Foods Market, and we want to be able to show items which are there right now in the store. And that's something really difficult to figure out. So one of the most important benefits of knowing real-time availability is that you can make your website represent the store better. You will show only those items which are there in the store right now. And obviously, if we show only items which are there, we will be able to deliver as promised. We will be able to deliver what you ordered. And it also increases shopper efficiency because shoppers are not spending time in searching for items which aren't even there. And there are tons of other benefits, which I'll get to later. So one of the key metrics that we track is what is the found rate, which is essentially what percentage of ordered items were we able to find in the store. And this is a key metric because higher this metric is, it means that we have been able to deliver what customers ordered. And one of the most important things which customers don't like is not getting like one single item which they had ordered, because even if there's one single item missing, they have to make a trip to the store again or go to some other store for that one item. So it's really, really important that we improve our found rate as much as possible. Then, so we do actually get a lot of data from retailers. So retailers send us like daily updates on what items are there across all their stores in US and Canada. We ingest that into our catalog and from catalog systems, and from catalog systems, it goes to the website where we don't show anything which the retailer explicitly has said is not there in the store. But there are a lot of problems with this data. Firstly, it's only daily updates. And as you know, grocery items can go out of stock within just a couple of hours. And I do have one example of such item, which I'll get to at the end. But there are tons of items which get restocked and which get like bought within next 3 hours. And it's just impossible to know their real-time availability using just this data. And a lot of times, retailers also don't have the exact data. So the model helps in like cleaning up this data which retailers send us. And so the other important aspect is findability of items. I don't know if you have experienced this, you go to a store, you're looking for one specific item, but you keep looking for it and you don't find it. And you go and ask the store employee and they just know where it is. And that exactly is findability. A lot of items are very difficult to find, and they could be because they are misplaced. Certain items like daily items are available only at certain point of time. A lot of them are just kept in promotion aisles, which in a way is ironic because that leads to lower sales because people can't find it. So yeah, so we want to capture all of these things and essentially try to predict, will the shopper be able to find this item in the store? So as a solution, so this was, I would say, this idea, like it came about 2 years ago, and according to like what systems we had then, I would say it was a crazy idea because there's so much data, customers data, shopper activity data, then we have retailer availability data coming in, and we want to like pull in all this data together and figure out what is the real-time availability of each and every item in our store. And to just give a number, right now there are 600 million items on Instacart's website, and that's a huge task. So yeah, let's come to the main part, training the model. I put this image on purpose because this was one of the ideas which we explored, having robots go into the store and scan the shelves to figure out real-time availability, but we realize it's just a logistical nightmare because we are operating in 20,000 stores. It's impossible to have 20,000 robots and make them go over the store. I'm sure the store employees are going to be pissed about these robots coming in their way. So it didn't work out. So we stick to machine learning itself. Yeah. So how do we build the trained data? So I've already given some hints. So one of the most important data is shopper scan activity. When a shopper scans an item and says that this item is there, or basically it's found, we know that it's going to be there in the store for next couple of hours because it's probably not going to run out that quickly. And vice versa, if the shopper says it's not there, it's not found, it's probably not going to be there for next 3 hours until it gets restocked. So these real-time signals help us in figuring out what is the real-time availability. And so to train the model, we basically just try to train the model to predict if that item is going to be a found or not found. So over here you see it's the x-axis is the time scale. I can just use the mouse pointer. Yeah. So this is item 1 which was found. There's this item 2 which was not found. And what we simply do is we just take each and every of these items, and that forms one row in the trained data. So item ID 1 found, yes. And for features, we take all the data that is there that we have for this item in the last 6 months and create all the features. So this is kind of like you don't stick to like one single time frame. We basically take these events from last 25 days. So that gives us like a lot of data. And that's what we train the model on. Then in terms of features, any guesses what features might work well? Yeah, but that's not the most important one. Sorry? Yeah, exactly. So one of the most important is time since last not found. When did the last scan occur, and was it a found or not found at that point? Then we use like a lot of other features like historic found rates for that item in last 6 months, 3 months, 1 month, and 1 day. Hour of day is an important feature. We typically see good availability of items in mornings when stores are restocked. And as we go along the day, the found rate keeps decreasing and the availability also keeps decreasing. So this is just one feature. On x-axis is time since last not found in hours, and y-axis you have the found rate. So this is, it was not found in last 1 hour, and that has the lowest found rate, which makes sense. And as you keep going, so this is, it was not found more than 50 hours ago, so basically 2 days ago. And if it was not found 2 days ago, that shouldn't really matter for today's prediction. And you see that found rate gets better for those items. And the last bin over here is the items which have never been not found. They have been found every single time, and they have the highest found rate. So it's features like this which help in predicting the real-time availability. And totally we have like 100 features. These are features with from different time periods, capturing different things. Now, so one of the most big problems that you face is long tail items. Long tail items are items which haven't been ordered before or have very few past orders. And the reason why this is concerning is because if you have an item which was bought, let's say 1 month ago, and let's say it was a found, that data point doesn't tell you anything because it was a found 1 month ago, and that's not going to have any correlation or any causation with today's found or not found, as compared to having a not found just 2 hours ago. So whatever features we discussed, except the hour of day, rest of the features are based on that item's past orders. And if there are no past orders, none of these features exist. And these items do form a significant portion of our order items, and they did impact the model performance negatively. So this was one problem. The other was with extremely high cardinality of features. So for each item, so an item is let's say Clover 2% milk in this specific store. But we also know what is the product ID. So product ID is essentially, it's a Clover milk, which is generic across US. And we have millions of products. So if you want to use product ID itself as a feature, you have a cardinality of millions, where cardinality is number of distinct categories. For example, store ID, since we have 20,000 stores, its cardinality is 20,000. And there's no way we can use these as one hot encoded because you would have probably tens of thousands of millions of features. The one other thing is it directly negatively impacts the scoring time as well, because if you one hot encode these features, your data size blows up, your RAM consumption blows up, and it impacts scoring as well. And scoring is a big concern because remember we have 600 million items and we want to score them like every 1 hour. So we came up with a very simple solution for this problem. One solution which tackles both the problems. So as I said, let's say you have Clover milk, which is a product, 2% Clover 2% milk, and an item is defined as the same Clover milk in store A, and item 2 is the same milk in store B. So till now we have been constraining ourselves to create features only from items past data. So if you want to create features for item 1, we just look at order specific only to that item. But over here we kind of zoom out and we start looking at the product across the US, and we create simple features like what has been the historic found rate for this product and not the item. So item ID 1 and 2, since they are the same products, they end up getting the same feature value, which is 80%, which is the found rate of Clover milk across US. Then this is Hershey's chocolate milk. Same thing. Its found rate across US for the product was 95%. I'll get to how these help in the long tail items. But before that, so instead of sticking to only product, since we have all these different categorical features like product, store, region, retailer, we do combinations of these. So one combination is what was the found rate for the product in the item's region. And this is more granular than just looking at the whole US, because you will be looking at what is the found rate for Clover milk in San Francisco. And this feature essentially captures how good the supply chains are for that product, because we don't have explicit data on the supply chain. But if we just look at what has been the found rate for this product in San Francisco, if it's like really low, let's say 10%, that's a good indication that there are some problems with this product and its supply chain, and maybe we shouldn't be showing it on the website. And yeah, so long tail items. So essentially, so Clover milk in store A might not have been bought before, but it's very likely that Clover milk has been bought somewhere in San Francisco. So since you're using data from specific to that product rather than item ID, these features exist for items which don't have any past orders because they're reliant on past orders of the product. Any questions or anything? Too fast, too slow? Okay. So yeah, this is the what improvement we got from these features. So if we don't use categorical at all, the model doesn't work at all for tail items. If we use them as one hot encoded, it's kind of better, 14%. But once we do this mean encoding, it's 100% better, twice as good. And it ended up being effective even for non-tail items because these features are applicable for all the items. And in terms of feature importance, the mean encoded ones are the most important. In fact, the most important one is what is the found rate for the product in that region. Then the item level features which we discussed are the second most important, and time-based features are the third one. So this is an example, really interesting example I came across. So anyone who loves oat milk, have you tried buying Oatly?
I tried buying Oatly at the Whole Foods next to me, but they never have it.
Yeah. So Vice News actually covered that. So Vice News has a really good report and a video on this. So I'll let you guys read what it says. So this made me curious. What does availability model has to say about this item? Since it's so bad in terms of like getting it. So I looked for scores for this item across US, and they were indeed phenomenally low across US. And they were low even in stores where they haven't been bought, and that's because we use these product level features. One store I looked at in Mission District, it had a score in bottom 2 percentile, and that would mean that this item won't show up on the website. And a lot of retailers are telling us that this item is there in the store, but it's actually not there. And in a way, it's ironic because we kind of know the retailer's inventory better than the retailer itself, in some cases. Yeah, and the actual found rate was also pretty low for this item. And I would definitely recommend you guys watching the video from Vice News. It's pretty interesting. So yeah, so that's about how we train the model. The next most important challenge was in terms of the product itself. So one of the things the first thing that we started doing with this was trying to nudge customers towards buying items which are easy to towards buying items which are easily available. And the main metric which we wanted to improve was the found rate. And the idea was very simple. People come on the website and search for something, and can we alter the search results in a way that pushes customers towards items with higher scores? And the moment customers start buying items with higher scores, that will lead to a higher found rate. And the counter metric was search conversion rate. Anything that we do with the search, it might lead to a drop in search conversion rate, and we don't want it to drop a lot. And the reason is that search conversion rate is typically a leading indicator of GMV, and I don't think our investors will like GMV going down. Yeah. So broadly we tried two variants. One was the demote variant, where we simply so with every search we pull the scores for each and every one of these items, and we demote items which have scores below some threshold. So the ones in red box are the ones with low scores, and they have been pushed to the bottom. And what this leads to is customers typically buy items which are at the top of the search results, and this kind of pushes the customers towards better availability items. So this did not lead to any drop in search conversion rate because we are still showing all the results. So if someone wants this item, they can still go and click on it and buy it. This also did not lead to a very huge improvement in found rate because people were still able to find these low score items. So the other variant which we tried was just completely hiding the items. So you won't see the red boxes in the actual search. You just won't see the items at all. So this led to a very good improvement in found rate because we are explicitly not allowing the customers to order these items. But the problem is it also led to a drop in search conversion rate, which is concerning. So essentially, now this is I would say a difficult problem because we don't know how to solve it. We want to go ahead with the hide variant, but the search conversion rate is dropping. So we wanted something which is very simple, which it's okay if it involves ML, but it has to be very simple. And the reason for that, I'll come to it. So let me just give a quick demo of. So we actually came up with a way to figure out if items are highly relevant. So this is a Wegmans store. I search for orange juice. I particularly like something called cold pressed juices, and it's not there. I can't. It's not there in this search result. But if I do a search for cold pressed orange juice, it shows up right there, this one. And this item has a low score right now, and it's being hidden across the website. But whenever a customer does a fairly specific search, like as I did for cold pressed, it shows up. And so I'll talk about how we figured this out. Like how do we know that this item is highly relevant and we shouldn't be hiding it? Yeah, sure.
Instead of hiding it, why wouldn't you put a tag saying this is a low stock item?
Yeah.
The shopper will buy it if it sees it, if it doesn't see it.
Yeah, so one of the concerns is our retailers don't like that because they don't want their customers to feel like this item is probably there, probably not there. They want their customers to know for sure what is there. And when we put that badge, it is very obvious that we are doing something with the search results. It also creates a doubt in the customer's mind. It basically kind of confuses them, like should I go with this or that? But that's something we have thought about. We did in fact try that treatment in one of the variants. It worked fairly well. But yeah, there are other reasons why we didn't do that finally. Does that answer the question? So yeah, so how do we figure out what not to hide? And one smart thing which we did was we just went back to the demote variant data. Demote variant data. So in demote variant, whenever a customer clicks on item which has been demoted, let's say this one, it means that item is highly relevant in that search, and we can use this data somehow and maybe train a model and then figure out what not to hide. Any guesses how do we do it? Any ideas? Yeah, I mean it's not that obvious, so I'll just go ahead. So I'll go back to that example again. So one of the things that we want to do, so when you search orange juice, you have a lot of different options for orange juice, and it's okay to hide like a couple of items in this page. So in this page, there is no unhiding happening because there are so many options. But the moment I do cold press, there are just about 6 results. And even in this result, there's only 2 orange juices. Rest of them are pretty irrelevant. So we want to figure out not just which items are highly relevant. It's fine if they are highly relevant and there are other replacement items showing up in the search. So we really want to unhide only when in that search, that is the only item which could be bought for that search query. Does that make sense? So what we simply did is we took each search and try to define the search context. Easiest way to define is number of search results in that page. The other thing is how many of the top 5 are we hiding? This should be hidden, not demoted. And if you look at the plot, so this is on x-axis you have number of items demoted in top 5, and y-axis you have percentage of times customer clicked on a demoted item. So the more you hide in top 5, customers tend to scroll down and pick an item from the demoted one. So this is still the demote variant. So customers can still see all the items. So whenever they scroll down and click, it means that we want to unhide it. And that typically happens a lot when we hide, let's say this is more than 3, when we hide more than 3 items in top 5. Now, and we did have like a lot of other features as well. But the problem is we want to implement this within search. Each search is different, so we can't like pre-compute these features for each search ahead of time. We have to compute these features when the user does a search, and somehow figure out what not to hide. So we basically came up with a very simple way to do it. So we just took each feature. This was actually the most important feature, and we said since this is a bad region where a lot of customers are going down and clicking on demoted items, let's not operate in this region. So any search where we hide more than 3 in top 5, we start unhiding one by one until we come back in the white region. And we chose about 3-4 features. We tried different variants in production and saw how the search conversion rates were, how the found rates were, and so finally we did see a slight dip in founded improvement as compared to hide, because now we are like showing up some of the items sometimes, but the search conversion rate was almost flat. So essentially we figured out a really good way to get the improvements from hide variant, but also keep the counter metrics as they were in demote variant, and that's an amazing thing. And we had a very simple solution for this as well. And the reason why I'm focusing on this is because a lot of times you will face problems like this, which don't have to do with machine learning, but it's all about being smart and looking what data you have and accordingly implementing a solution which works. So it's not about everything is not about machine learning models. So this was the product use case. Do we have time? Yep. So let's come to the scoring pipeline. So as I said, we have about 600 million items. The reason why this number is so huge because we are operating in 20,000 stores, and each of those 20,000 stores probably have like 50,000 items, and that comes to about 600 million items. And it's impossible to score all of them. So I'll get to how the scoring works, but this is the architecture. So this is the training pipeline. All our data resides in the Snowflake data warehouse. This pipeline runs once a week. We create all the trained data and the features. We download it to a AWS training instance. AWS instance for training. We train the model and upload it to S3 where we save the trained model. Then for scoring, this pipeline runs every 30 minutes. Sorry. We again hit Snowflake, create features for items as of now. We pull the trained model from S3 where it was saved, do all the scoring and upload it to a Postgres table. And from there, it gets circulated to all the use cases. One use case is the search, the website itself. So whenever a user performs a search, we pull or fetch scores for all the items in that search and hide items based on low scores and low relevance. So, so I probably won't go into like all the details, but I'm happy to like jump into the technical engineering aspects as well. But I'll go through like key highlights for now. So we actually rewrote the whole scoring pipeline from scratch about 6 months ago, and we got some phenomenal scaling improvement. We started scoring 15x items in 1/4 time, and while taking just 1/5 of the resources previously used, and that's about like 300x scaling. This made the whole, so the model used to take like days and days to like just get scores for, let's say, 40 million items. But the new one, it gives you scores for 240 million items within just half an hour. And the way we achieved it is end-to-end parallelized scoring. So there's nothing in the scoring pipeline which is not parallelized. Each and everything is parallelized, and that includes downloading the data from Snowflake, doing all data processing, and the actual scoring itself. The other thing which we made sure was it's linearly scalable. The scoring pipeline has been built in a way that even if we want to score 10x items, we will be able to do it, but probably in just like 10x the time, but we won't face any memory issues. And that's important because Instacart has been growing rapidly. We have seen like triple-digit growth in last 3 years. So we have, as a machine learning team, we have to be prepared for the growth as well. And there are other things which we did on purpose. There is zero feature engineering happening in Python. Each and every feature gets created in SQL, in Snowflake. I can get into like why we did that in Q&A. Then the last thing which we did was feature caching. A lot of features like, let's say, found rate for a product. Found rate for a product is not going to change every hour. So instead of computing them for every half an hour batch, we cache them and we update them probably once a day. And this helps in reducing the scoring time because you're not computing all the features from scratch every single time. So yeah, so what we have right now is, so we don't score all the items because not all of them get bought. We prioritize which items we want to score. So we right now score about 250 million items. They get scored in half an hour. And yeah, feel free to ask questions on this if you want to know things in detail. But the main reason why I'm here is for letting you guys know that Instacart is hiring. So broadly we have data scientist positions and machine learning positions. Machine learning is basically people like me who build models, build the engineering architecture and things like that. Data scientists are who I would say it's a more product focused role. You tend to work on not building a machine learning model per se, but you work on product problems which can be solved using data. And so one of the things could be monitoring if A/B tests are going well. How do we take a call on A/B test? Has it reached significance? There's a lot of analysis that goes into when we make product changes. So data scientists are extremely useful over there, and I would say both of these roles are really interesting. In terms of like problems, any problem you name, we have that. Recommendations, logistics, search ranking. In fact, because of the way Instacart's business has been designed, we have completely new problems. Like item availability is not a problem which other companies face. The other big problem which I'm working right now on is the replacements model. So whenever an item is not found, we want to tell the shopper that this is a good replacement for this item. Or on the website, if we know that the item which the customer is ordering is very likely to be not found, we ask the customer which replacements do we want, and we show our replacement recommendations from the model to the customer. And that replacements model itself, I would say, is at a much bigger scale than this model, because this model basically the scoring time is linearly proportional to the number of items. But the replacements model is basically you have this item, and out of all the other items you have, which one is a good replacement? So that's basically a n squared problem. I'm having a nightmare to scale it right now. But yeah. So yeah, the other thing which I wanted to focus on is the culture. I've realized one of the things why I've been so productive at Instacart is a great culture, and I like defining Instacart's culture as something which is built on ownership and trust. You have to own the problems, and people will just trust you with what you're doing. And that's a great place to be in, because that's where you have the freedom to explore. That's where you have freedom to understand what problems are there and if machine learning can be applied over there. And yeah, you can reach me out. My username is Abhay Pawar on all of these three. It's same on Facebook as well. If I don't think anyone wants to add me on Facebook, but still. And that's my email ID. So feel free to reach out. I do respond on LinkedIn, unlike a lot of other people. So yeah. Yeah, and happy to take any more questions, or I can go into depth about any of these things. Feel free to ask questions about Instacart positions, the machine learning, or machine learning in general. Yeah.